Okay, let's look at some problems for 3.1. So here we're going to learn about the basic functions and their graphs. So first, make sure you review the basic functions. They're clearly gone over in the book. And on page 217, 218, it has this nice summary of all the basic functions. So far we've learned 7 basic functions. On the test, I will give you 3 of these and you will have to give me back the graph, the name, the algebraic representation, the domain, the range, and the symmetry. So make sure you're very comfortable with these 7 graphs. So our first problem says, determine the basic function. So all they're asking for here is look at the shape and decide which of those 7 functions it looks like. Well, that's definitely a parabola, right? So I come up here and I say a parabola is my square function. I can see that's the graph of a parabola. So that's my basic function. So I have to memorize that the basic function for parabola is y is equal to x squared. We call this a square function. Okay, the next part asks me to find if there are any zeros. So the zeros of a function are the x values for which f of x is equal to 0. Another way we could say this is it's the places where it crosses over the x-axis. So a function could have no zeros, 1 0, or many zeros. So let's look at our question. I can see that we cross over the x-axis twice. These are my zeros. So my 0 would be at -6 and at -2. Our next problem asks us to graph the function and approximate the zeros to 4 decimal places. So we need to get out those graphing calculators. Okay, so to graph your function, we're going to use our grapher. And when I say that, I'm just meaning you click on the y equals button. Okay, if you already have a function there, you're going to hit clear. Okay, so I've clicked on my y equals, I've cleared out any functions, and I'm going to type in my function. So let's type that in. Now, when I have an exponent, I can use this little up arrow. It's a little caret. Make sure you arrow over it when you're done with it. Notice for the x, I'm using the xt theta n button. There, I've entered in my function. Now, if I hit graph, I'll get a standard window. A standard window is 10 to the right, 10 to the left, 10 up, and 10 down. So sometimes we're going to need to adjust the window view so that we can see our function. Maybe it's not in that 10 by 10 area. So for example, what we're doing is our window looks like this. So if our function's not inside, if it's not in here, say our function were outside of that, it won't show up on the calculator and we'll have to adjust our window. But lucky for us, when I hit graph, our function is inside of our window. Okay? And we can see that looks to me like it's a cubic function from the graph, right? Which would agree with, we can see that the function over here has a 3 for the exponent. Okay, next it asks us to approximate the zeros to 4 decimal places. Now, we know the zeros are the places that it crosses the x-axis. And I can see from my graph that's at least crossing at 1 here. So let's use our calculator to find that one out, okay? The way I find it out is I hit y equal again. Now, we're going to do a little trick. We already have the function graphed. So now we're going to graph the x-axis. So the equation for the x-axis is y is equal to 0. So now I have 2 functions graphed. What I've done is I've graphed my first function, and now I just graphed that x-axis, y is equal to 0. And I'm going to use the trick of, I'm going to find where they intersect. So I'm looking for this spot right here. And I'm going to use the intersect tool on the calculator. So we've entered our two equations, the function we want to look at, and then y is equal to 0, which is this our plain old x-axis. Okay? If I hit second trace, this is really where we have all our calculate features. Now I'm going to use 5 for intersect. Okay? And I can just hit enter, 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 and it will give me my answer. So if you notice, I hit 3 enters, and it gave me my intersection. So you can see we're intersecting at when x is 0.7926859 and y is equal to 0. My zeros will always have y equal to 0. Now, the problem asks us to approximate to 4 decimal places. So let's just review rounding. When I want to round to 4 decimal places, I underline my 4th decimal place. And then I look at the one to the right of it. So I'm going to consider the one to the right of the decimal place I'm rounding to, which in our case is an 8. If the number is 5 or greater, then I'm going to round up. So since 8 is greater than 5, I remove 8599 and I increase this by 1 digit. So my 0 is 0.7927. So our 0 would be when x equals 0.7927. Now remember, there could be more than one, or maybe there's none, so be careful. This is a really important technique to find the zeros, and we're going to use this so many times in this class. It will really be a really big help if you're comfortable with this technique. So I'm going to do it for another problem here. So I come into my calculator, and I enter in my equation in my grapher. My grapher I'm referring to as this y equals button, okay? If there's already a function, make sure you clear it. I use xt theta n for my variable, and I use a caret for any kind of exponent. So whenever you want to use the intersect key to find out your zeros, you're going to want to enter your function in for y1, and you're going to enter in y2 is equal to 0 for your second equation. Okay? Let's graph them. Now I can see clearly that I'm crossing my x-axis 2 times. So to find those 2 places, I'm going to say second trace 5. It's looking for the 2 intersections, and I'm just going to hit enter 3 times. 1, 2, 3. That's going to find one of my zeros. So my first 0 is an x is equal to -5. Let me write that one down. Okay, so you have two intersections with the x-axis, so you have 2 zeros. To find the second 0, I'm going to repeat the process. Second trace 5. But instead of hitting enter, 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 before I do that, I'm going to use my arrow key, right or left, to just go near the 0 that I want to calculate. So I'm just going over with my right. Notice my little spider's missing. It's giving me the coordinates of where he's at. He's coming up. There he is. Okay, so anywhere near the 0, and then I hit 3 times enter again. 1, 2, 3. And it says my other 0 is at x is equal to 6. So that's how you find when you have multiple zeros. Now, there's another method you can use in your calculator, and it's called 0. So it's also on that calculate field, and you're welcome to read about it in your book. If you want to use this method, it's on page 222 and 223. But I think that the intersect method, I've had a lot more success with students getting it right. So try them both, see what you like. Okay, our next problem is about whether a function is even odd, or neither. Okay, so we need to memorize that an even function means that if you have an input of negative x, the output will be the same if you have an input of positive x. In other words, you can put in a positive value for x, and you can put the same value in, but make it a negative value for the same x, and you'll get the same output, okay? An odd function, when you put in the opposite value for x, instead of getting the same output for y, you'll get the opposite. You'll get a negative value for y, okay? Now, let's just try this. So algebraically, we can check this out. So what I'm going to do is I'm going to first say, is it an even function? And it's a really easy thing to do. Just replace any x with a negative x. So I wrote down the same function, and wherever there was an x, I just changed it out for a negative x. And now I'm just going to simplify this. So we know that a negative x raised to the fourth power, well, that's a negative times a negative times a negative times a negative. So that's going to give me a positive. Similarly, negative x squared will also give me a positive. So you can see that f at negative x is the same as f as positive x. They have the same value now. So since f at negative x is equal to f at x, we know this is an even function. So I always check that one first. And if it's not even, then I try odd. Now, it asks us to confirm it graphically. So let's just review what an even function should look like if you graph it. So when you have an even function, it should be symmetrical about the y-axis. That means if you were to fold your paper in half along the y-axis, right, then it will mirror both sides. So for example, you can see that this side is a mirror image of the other side. If you fold it in half, they would lay on top of each other. So let's check ours out. So we're going to graph it. Once again, we're going to use our grapher, the y equals button. Oh. Clear any functions you have. And I had one earlier, so I'm going to clear this. I only need to have everything cleared. And I'm going to enter in my equation. I'm going to hit graph. Now, you can look at it and you can say, if you folded it in half along the y-axis, would it lay on each other? And it does. We can see clearly that it is symmetrical about the y-axis. It's an even function. Let's try another function. This time we have 4x cubed minus 1. So let's check. First, let's see if it's an even function. We check by replacing the x with a negative x. So wherever there was a positive x, I replaced it with a negative x. And now we simplify it. Well, a negative times a negative times a negative is a negative. So this will become negative 4x cubed minus 1. Now, these are not the same. So it is not an even function. So let's cross that one out. So we have to check to see if it's an odd function. So the way we check to see if it's an odd function is we look and we say, when we replace it with a negative x, we check to see if f at negative x, what we have here, is equal to a negative f of x. So what we need to do is we need to figure out what negative f of x is. So we take our function that we started with, and we multiply it times a negative 1. Okay? And this would now become negative 4x cubed plus 1. So we can see now that negative f of x is equal to negative 4x cubed plus 1. So if these were odd, negative f of x would have to equal f at negative x. So that's why I check my even one first, because I need it anyways. These are not equal, so it is not odd. So I'll say it's neither. You can check this also on the calculator. We said that an even function would be mirrored about the y-axis. Well, an odd function is even easier to check on the calculator. Once again, I go into my grapher and I type in 4x cubed minus 1, and I graph it. Now, what's so great about the calculator is you can check an odd function very easily. What I want to do is I want to take my calculator and just rotate it around upside down like that. Once you hold it upside down, it should look like the original graph you started with. Now, if you notice, it sort of does, but look closer and notice that the first graph that we started with, the intersection with the y-axis was below the x-axis, and the one when we hold it upside down is above the x-axis. They'd have to be identical for it to be an odd function. So let me say that little trick again. If you want to find out if a function is odd or not, just take your calculator and hold it upside down, rotate it around. There you go. It needs to look exactly like it started with. If it's exactly the same picture, then it's odd. If it's not, it's neither. Our next problem asks us to state the domain and range of the function. So we know that domain means these are all the allowable x values we can have. So we're going to always go from our farthest left value to our farthest right value on our function. So what's the farthest we can go and be on our function? Right here, right? And what's the farthest right we can go? All the way over here, right? So our domain would be -4 to 7. Now, we're going to use brackets because both those ends are closed circles. Now our range, we're going to always go our lowest value to our highest value. The lowest value on our function would be -2. And our highest value on our function would be 4. So our range would be -2 to 4. Part B asks us to state any relative minima and maxima in ordered pair. So our relative minima and maxima are our turning points. So we can see we go from increasing to decreasing here, and from decreasing to increasing here, and from increasing to decreasing here. So these are the 3 points we're going to look at. And you can see that these are going to be relative maxima, and this one's going to be a relative minima. So relative minima are going to be our valleys, and relative maxima are going to be our mountaintops. Okay, so let's state any of these. So the first one would be our relative minima would be -1, -2, and our relative maxima would be -3, 2, and 5, 4. We do not include the endpoints when we're talking about relative minima and relative maxima. They're not turning points. Part C asks us to state any absolute maximum or minimums on the graph. So this is saying overall, anywhere in the entire domain, what is the maximum or the minimum? So let's see if we have any. So our highest point on our graph is going to be right here, right? So and then our lowest point on our graph is going to be right here. So those are going to be our two points, our absolute maximum and our absolute minimum. 5, 4, and our absolute minimum will be -1, -2. Little Susie notices the neighbor's dog outside her third-floor apartment window, and she decides to throw a dog treat out of the window, making sure it hits the sidewalk and not the dog. Her apartment window is 28 feet above the ground. The height, h, in feet of the dog treat can be described by the function h of t is equal to negative 16t squared plus 28, where t is the time in seconds. So they ask us to graph this on our calculator. And I wanted to use this one to show you how to use to change your window. So a standard window on their calculator we mentioned earlier is 10 by negative 10, 10 up, and 10 down. Okay? This is standard, but a lot of times it won't be enough or won't be correct for graphing what we want to see. So sometimes they'll give us actually the specifications of the window. And when they do, it will look like this. So this is telling you what to enter into your window. Which, when you see this, they're telling you what X min is, what X max is, and then your X scale. And they're also giving you the Y values. All right, so these specifications tell you what the graph's going to look like. On ours, our x-axis will go from 0 to 2. And it says the scale is 0.5, so it's going to go 0.5, 1, and 1.5. So the scale tells me the distance between the little tick marks. My y-axis is going to go from 0 to 35. But it tells me that my y-axis, the little tick marks, will be worth 5 each. So these window specifications tell you that on your calculator now, you're only going to see the area that's been specified in the window. So let's see what it looks like on the calculator. So I already entered into my grapher. Make sure when you enter a negative that you use the bottom row key in parentheses, that's a negative, not the minus. It will give you an error. Okay? I changed my window based on the specifications they gave me, and then I hit graph. And you can see now, we can see a picture of what the function is doing in the window they want us to see it. Part B asks me to find the zero of this function and interpret its meaning in the context of the problem. Now, remember, an easy way to find a zero is just to put in a second equation of y is equal to 0. We know that y is equal to 0 is the x-axis. So we're going to use the intersect function to see where the function intersects the x-axis. So I hit second, trace, 5. And then I hit enter 3 times, 1, 2, 3. And it says that the zero will be at 1.3228757. And it tells us to round to 2 decimal places. So let's go over that one more time. So when I round to 2 decimal places, I want to underline the second decimal place. But I want to look at the one to its right. If the number is 5 or greater, then I'll change my underlined number by raising it 1. If my number is less than 5, then I will leave my underlined number alone and just remove all the numbers that follow it. So my 0 is x is equal to 1.32. It asks us to interpret the meaning in the context of this problem. So if you remember, this was the path of our dog treat that we're throwing out the window. So our x-axis was time, and our y-axis was height. So when it falls to the ground, it will be 1.32 seconds.